Hi, I'm Andrea and welcome to Productive C#. In this video, I want to talk about the Read-Only Members feature introduced in C# 8. Here I have a console application targeting the core tree. I have a struct vector that contains two properties, x and y, and a toString method that print the x and y of the vector and then also increments the values by 1. The program is creating a vector, then calling print twice, and the print method is printing the result of toString twice. So I invite you to pause the video and think about what this program will print to the screen when I run it. Okay, let's have a look. It's printing 1, 2, 2, 3, and then 1, 2, 2, 3. Okay, why? So you know that in C#, when you pass a struct as an argument to a method, the struct will always be copied and passed by value. So this means that the variable that you are using when you inside a method will always be different. So there will be always a copy of v happening when you call each method. And this is why the two lines are effectively identical. However, when you call toString here the first time inside the method, the struct v, actually the copy that has been done of the initial v vector that is passed to the print, will effectively change because toString is incrementing x and y by 1. So the second time toString is called, now is using the same struct as before, and now the value are 2 and 3 because they are 1 and 2 incremented by 1. Okay, and that's why this is happening. So if I instead pass the struct by reference using the ref keyword, this has always been available since the beginning of C#. If I run this code now, you will see that you get 1, 2, 2, 3, 3, 4, and 4, 5. So the code is always using the same struct under the covers. So even if the struct is passed to the functions, now the struct is passed by reference. So v always change every time you call toString, and then we effectively always increment the values and print the new values. Okay. Now if I remove ref and instead of that I use the in keyword, so now what happened? Again, try to pause the video, think what will be printed to the console. Now let's run it and see. Now it's printing 1, 2, 1, 2, 1, 2, 1, 2 all the time. What's going on? When you specify the in keyword, you are telling the compiler that you want to pass the struct by reference, but you're telling the compiler that the method will never change the struct. However, because toString is called, the compiler has no way to know if the toString is going to actually change the struct values. And then, because of that, the compiler is forced to create a defensive copy of the struct every single time method of this struct is called. So every time toString is called inside this method, the compiler is creating a defensive copy and running toString on that copy. So because it's always creating a copy every time the toString is called, effectively you are always using the initial struct when you call toString. It's always going to print 1 and 2. So that's very interesting. Okay. So let's have a look a bit more closely by decompiling the DLL. So if I go and open JetBrains.py and I right-click on program and do decompile sources, I'm also opening an IL viewer to see the actual IL. Try again. There we go. And I go into the print method. Obviously, you don't need to understand how IL works. I just wanted to show you that what .NET is doing, the actual C# compiler is doing, is creating a local variable here called v_0 using local init, and here before calling toString every time is creating a copy using these instructions. So every time toString is called, it's creating a copy with 0 and using that to call toString, and the same here. Okay. Now let's see what I can do when I use read-only members in C#8. So what I can do in C#8 is I can say, okay, please, this method, make this method read-only. Okay. When you do that, you are telling the compiler that this method toString is never going to change the struct. Even if the struct is mutable, as you can see, x and y contains setters, so effectively it's mutable, the compiler now knows that this method will not change the vector. In fact, it's actually giving a compiler error because you are actually changing x and y. In order to make this to compile, you need to remove plus plus and plus plus. So now the compiler knows that this method is always read-only, so it's never going to change the struct. Actually, is enforcing it. But in addition to that, even if the overall struct is mutable, the fact that you marked the method as read-only means that the compiler can be smarter in performance optimization. And when it comes to calling toString here, the compiler doesn't do, in this case, a copy, a defensive copy of the struct, because the compiler knows that toString now is read-only. It's not going to change the struct, so the compiler knows that is able to honor the in parameter in this case. So if I run this code, it's still going to print the same result, 1, 2, 1, 2, 1, 2, and 1, 2. So the external behavior hasn't changed. But if I now go back to JetBrains.pick and I look inside the print method, you can see that now we do not create this temporary v_0 variables here. We are actually calling toString directly on the struct. So it's effectively using less memory in order to run this program. So this is basically where the power of these read-only keywords comes. When you have a struct and you need to have this struct to be mutable, but you know that some methods never going to change this struct, please just add read-only to it, because the compiler can improve and optimize your code without you to do anything and without any behavioral changes. And in addition to that, you also get the compiler's ability to enforce that the code effectively is not modifying your struct. Said that, of course, using the read-only keyword on a struct directly is usually better, because it's a good practice to make your structs immutable, and that was basically added in C# 7.2, the ability to add a read-only keyword to the entire struct. However, in C# 8, you can also add a read-only keyword to particular members, methods, or properties, or indexers, for example, even if the overall struct is not read-only. That wasn't possible before. So you can still enable some performance optimization, even if you still want to keep your struct to be in a mutable way. And that's effectively what this feature is all about. So going forward, when you work with structs, if you can, always make your struct read-only and immutables. In that case, you always get the best possible performance when you use your structs. However, if you still want your struct to be mutable, make sure you add the read-only keyword to every single method or properties that you need, to make that that is read-only, so that the compilers can optimize your code, and you can also, make sure that you effectively honoring that read-only keyword. You are not going to change the struct. Another small note is that if you use automatic properties, read-only automatic properties, the C# compiler, starting from version 8, is automatically adding the read-only keyword for you. So if, for example, I remove this private setter here and here, even if I do not mark the struct as read-only, the x and y properties are effectively read-only. Okay, so that's it for this feature. Thank you very much for listening.